Graphical representation of a quadratic equation. We would like to understand when a quadratic equation is plotted on a xy plane, how it looks like. So a quadratic equation is given by y equal to ax square plus bx plus c. The graphical representation of a quadratic equation is often known as a parabola. Parabola has a shape that is graphically known as by the shape of like this. So let us draw on a xy plane, and then we're going to draw this equation. So this shape is called a parabola. So this is the shape of a quadratic equation, but often it is called as parabola. Now some of the key points of this curve is this point where it intercepts the y-axis is called the y-intercept, and it has a value of c. So the constant c in this equation that you see here is the y-intercept. The reason is when you substitute x is equal to 0, you get y equal to c. So therefore this coordinate is called c when it intersects. Now these 2 points where the parabola is intersecting the x-axis are called the roots. So we can label them as x is equal to p, y equal to 0, x is equal to q, y equal to 0. So if we assume that p and q are the roots, then p0, q0 are the 2 points on the xy plane where the parabola or the quadratic curve intersects the x-axis. This line of symmetry is also known as the axis of symmetry, and it has a special property that it passes through the vertex or the lowest point in the parabola and is parallel to y-axis. So we can actually label this as vertex, and let's write them as. Now another thing is the p and q, the 2 points shown on this parabola, are equidistant. The reason is axis of symmetry is equidistant. Every point on the parabola on the left and right of the axis of symmetry are equidistant. So this vertex is the lowest point. The axis of symmetry passes through the vertex and it is symmetric. Every point is equidistant. We can also write the formula for vertex in terms of these coefficients a, b and c as minus. So the x coordinate will be minus b by 2a. The y coordinate is minus b square minus 4ac by 4a. One easy way to remember this y coordinate is minus d by 4a, because the numerator b square minus 4ac is also called as discriminant. So if you think, you sometimes can get confused as to the values, you think about it as a minus d by 4a. The x coordinate is easy to remember, and many people do remember this as minus b by 2a. They may sometimes get confused with the y coordinate, so it is often a good and easy way to remember as d by 4a, minus d by 4a, and so that is the vertex. And now when we can also represent the same quadratic equation in a binomial square form or a vertex form, we call it. So if it is a into x minus h square plus k, so in this case the parabola is also like that, but the vertex point is called as h and k because it is written in a vertex form. So h and k happens to be the vertex. Now we can also write it as in a factor form. So if we let p and q be the factors, then the equation is a into x minus p times x minus q, where p and q are the roots and x minus p and x minus q are the factors. So we label them as p and q. This point is, if a is not equal to 1, then it becomes the product of a times p times q. You can at least see by multiplying that you get a term called apq. If a is 1, then it is pq, otherwise it is apq. Now we can also draw this vertex. Vertex will be, remember that if p and q are the roots, the vertex can also be called as p plus q by 2, because it is equidistant from all the points on the parabola on either side of the axis of symmetry. Now what else? So another thing is, if you want to understand what is a here, so if I draw two parabolas, both having passing through the origin, so this stretch factor is called a. So a is graphically, the meaning of a is a stretch factor. So this is a, this is a. Only thing is the a for this will be less. So if I say this is a1 and a2, the wider the parabola, the smaller the value. So a1 is less than a2, because as it keeps becoming wider and wider, as it bulges out, the a becomes less and less. Similarly, when the parabola is downward, we call a is less than 0. When the parabola opens upwards, we call a is greater than 0. What else? So we can also say that when a parabola intersects or touches the x-axis at one point, there is only one root, and when it does not touch, just as it's shown here, then it has no roots and the discriminant is less than 0. In this case, discriminant is less than 0. In this case, discriminant is equal to 0. And in this case, when it intersects, discriminant is greater than 0. So these are all the various things. But most importantly, what we wanted to show was, because this equation is having a degree power 2, that means it will always have two roots, two distinct roots, or at the most two roots. And similarly, like when an equation has y equal to mx plus c has one root, because x degree is 1, and similarly the quadratic will have two roots because of the virtue of the fact that the highest power of x is 2. And this shape is called parabola, and this is very important property. The reason is because in the real world there are many objects that have a motion or travel in this shape, especially when you are playing basketball. You know that when you try to make a basket or throw a ball, the ball travels in a parabolic motion, and that can be modeled using this quadratic equation. So this quadratic equation is so important because many real world problems, motion of this is represented by this equation. And these are some of the important properties. You should understand about A, B and C, and then you should also understand about the vertex axis of symmetry and how the roots are and the intercept and various other things. So the graphical representation of a quadratic equation is a parabola.